Girls, we are going to look at a couple of trigonometric identities or relations. But before we do, let's just start with a simple example, all right? Let's have a look at this triangle, okay? Let's just focus on that 30 degrees for now. Just ignore the 60. What's sine 30 from this triangle? Because from here, we know this is the opposite hypotenuse and adjacent, yeah? Focusing on the 30, ignore the 60. So sine is opposite over hypotenuse. So that's 4/5, yeah? Now, girls, I'm going to rub this out. Listening. I'm going to rub this out. Girls, this time, I want you to ignore the 30 and focus on the 60 only, okay? From the 60 degrees, the opposite to that is 3. The hypotenuse is still 5, but the adjacent is now 4, yeah? So what's cosine of 60? Adjacent over hypotenuse, in this case, is 4/5. So what the point I'm trying to make is, girls, can you see that sine 30 is equal to cosine 60? Yeah? So I'm going to write this. So sine 30 is equal to cosine 60 because they're both equal to 4/5. Girls, this means sine 30 is equal to cosine. Girls, instead of writing 60, this is the same thing as writing 90 minus 30, isn't it? Because 60 is 90 minus 30. Yeah? Girls, what I'm trying to say is, for this reason, girls, with any general angle, sine theta is equal to cosine 90 minus theta. Sine is complementary of cosine. So any angle here, if you want to change sine into cos, you just take that away from 90 and they're the same value. Okay? As we can see from these two examples, they're the same value. It goes the other way as well. Cosine theta, if I want to change cosine into sine, what do I write? What's it? 90 minus theta, okay? So cosine is complementary of sine. Sine is also complementary of cos, okay? So in other words, if you want to go back and forth from these two, take the angle away from 90 degrees. All right? So for example, if I wanted to change sine 47 to cosine, so that's the unknown, what you need to do is take that angle away from
90.
Yeah, so you do 90 minus 47. So in terms of cosine, what's 90 take away 47? 43, okay? All right? So it's just a basic fact. If you want to change from sine to cosine, take it away from 90. All right? Similarly here, if I want to simplify that, notice how this is in cosine, this is in sine. So it doesn't matter which one you change. Let's change that cosine into sine. So if I want to change this into sine, that's 90 take away 22, take away that. Yeah, and can you see that this will now become? Yeah, sine 68, take away sine 68, and that is equal to 0. Yeah? Now that we know that, let's have a look at this type of question. Girls, if sine alpha is equal to 5/3 and alpha plus beta equals to 90, find these three. Okay, this is actually quite a confusing problem if you don't know to do this. The first thing you want to do is draw a right angle triangle and you'll see why. All right, so we've got a right angle triangle and see how it says alpha. So let's mark that the angle. All right, so from there, girls, we know sine is opposite over hypotenuse. So what's that length? Yeah. And the hypotenuse? 13. Now, in order to find this one, it's a right triangle, so I can use what to find that? Pythagoras. Yeah? So 13 squared take away 5 squared. If you do that, okay, so this side is 12. All right? The reason why we need those three is because we can now use that to find these three. Now, before we do that, notice how it says alpha plus beta is equal to 90. What that implies is that angle is beta. Does that make sense? Because these two has to add up to 90 because 90 plus 90 is 180, which is angle sum of triangle. That's what this means, which makes the problem look a lot more confusing if you don't see it by diagram. Okay? So yeah, so the fact that we're given these two, now let's find that. So cosine beta. So that means we are going to just focus on that angle only, ignoring the alpha. Let's label the triangles, focusing on that. So opposite, so I'm just going to get rid of this now. Opposite of beta is opposite. So I'll write opposite here. Okay. and this is always going to be the hypotenuse because it's the longer side, and this is the adjacent. So what does cosine beta equal to? 5 of 13 because adjacent over hypotenuse. Let's keep going. Let's just do the ones with beta because we're on beta right now. Sine beta is equal to then?
5 over 13. What?
Sine opposite of a hypotenuse? Yeah. Yeah? Now let's do the same thing for this question, cosine alpha. So that means now we're going to focus on that angle. So now the opposite is the 5. Okay, and this is the adjacent. Hypotenuse stays the same. So what's sine beta? Oh, sorry, not sine beta. What's cosine alpha?
5 over 12. Nope.
Adjacent of a hypotenuse? Adjacent of, yeah. Yeah, it is confusing. That's why you want to draw this triangle out. Yeah, do you see the problem? So when they give you any problem like this, with a trig ratio with a certain number, draw the triangle out. Girls, this is one fact on trigonometry. Now, this is the most important part that you will need all the way to year 12, and it's called exact values, okay? So, girls, if you type in root 3 over 2, you're going to get that decimal number, 0.86. So when you see that number in the calculator, it's root 3 over 2. If you see 0.70 and recurring, it's always root 2 over 2. I want you to remember these two numbers because these two fractions cover almost every one of these exact trig values. The reason why if you have a look, you can see we're actually focusing on certain values, 30 degrees, 45 and 60 degrees. Those are your special trigonometric values that you can use later on with different identities. But for now, we need to know all these exact values. Okay? So, girls, you need to take your calculator out. I want you to type in sine 30 for me. What do you get? Yeah, sine 30, you'll get 0.5. That's obvious as a fraction. What's that? 1 over 2. Let's keep going. If you type in cosine 30, what do you get? You get 0.86 and onwards, and that's that one. All right? Now, we're going to leave tan for later. We're just going to focus on sine and cosine for now. What's sine 45?
0.7.
0.7. So what's that? Yeah, root 2 over 2. Okay. How about cosine 45? 0.7, which is root 2 over 2. Yeah, this is technically 1 over root 2 as well, but the reason why I don't use that one, I'll explain later. Yeah. What do you think that's for later? No, I get it. That's the proof behind why these are the exact values. For now, I'm just going to show you how to get the exact values because in actual problems in year 11 to 12, you're not going to really use that triangle to get the answers quickly. I'm just showing you the method to get the answers quicker than having to use that, which I'll explain later on. If you type in sine 60, what do you get? Yeah, it's 0.86, so that's root 3 over 2. And cosine 60? Yeah, 1 over 2. Okay? Girls, yeah, this is a quick way of getting the exact values, okay, if you ever need to get them in the exam. Now,
So we have to memorize it?
yes, but these two are the ones you must remember, and one more thing. Girls, tan 30 is a special one. I want you to remember tan 30. Tan 30 is 1 over root 3. Okay? If you actually type in tan 30, you're going to get 0.57 and onwards, which is the same thing as typing 1 over root 3. And if you type that in, it's also 0.57. Okay? An easy way to remember tan 30 and tan 45 and tan 60, girls, the top one, the value of 1, is the same for tan 45. If you type in tan 45, you'll get 1. But for tan 60, take the bottom one, it's just root 3. Okay? So that's how you memorize tan 30, 45, 60. Take the top for the bottom, that one, take the bottom for the second one. Now, you might be wondering how these values actually come about. Okay? This is the part you got to understand this proof. All right? So girls, let's say I have a right isosceles triangle where the opposite and the adjacent is both 1 unit. Okay? If it's isosceles right triangle, the angles must be what? Equal. But do you know what value? 45. Okay? Because 45 plus 45 is 90. 90 plus 90 is 180. So it has to add up to 180. Now, if that's 1 and 1, girls, what's that length? Using Pythagoras. 1 squared plus 1 squared? Root 2. Okay? So girls, let's use those values to figure out those. Okay? Since they're both 45, let's just ignore this one. Let's just use this one as our main focus angle. This is your opposite. This is your hypotenuse. This is your adjacent. Okay? We know sine is opposite of adjacent, yes? So that in this case is? Yeah, 1 over root 2. Girls, just a note, 1 over root 2 is the same thing as root 2 over 2, which I've taught you there. Can you see why? If you rationalize this fraction, how do you rationalize it? Times the top and the bottom by the denominator, you'll get that. Okay? The reason why I prefer to use that and memorize that is just because it makes memorization easier. Because you've got root 3, you see how root 3 and root 2, it's similar. They both got, it's like 3 and 2. If you have 1 over root 2, you can use that, same thing. But for me, it just makes memorization of these exact values a bit more difficult. So I prefer to use root 2 over 2 than 1 over root 2. And it's rationalized. Okay? Same thing for cosine 45. That's adjacent over hypotenuse. What is it in this case? Yeah, 1 over root 2. Or root 2 over 2. Okay? How about tan 45? Opposite of adjacent? Yeah, so as you can see, these are the values that I had over there. Yeah, sine 45, cosine 45, tan 45. Those are the values that I wrote over there. Now, with the other values, girls, consider this equilateral triangle. Equilateral triangle, all angles are what? Yeah, so we know these three angles are all 60 degrees. Now, if I split the 60 degrees into two triangles, what is it?
30.
It's 30 angles each, right? So what I'm going to do is cut one of those out, and I'd redraw it here. So we know this is 30. This is 60. What's that? What's that length? Yeah, can you see why it's 1? Yeah, because half of 2 is 1. Now, this one, using Pythagoras, is what? 2 squared take away 1 squared? Root 3. All right, so we're going to focus on the angle 30. So let's ignore the 60 for now. So that's the opposite. This is the hypotenuse. This is adjacent. So what sign? Opposite over hypotenuse. 1 over 2. Yeah, which is exactly what I had here. Cosine 30, we should get root 3 over 2, and which is the case here, adjacent over hypotenuse. How about tan 30? Yeah, girls, you get the idea, okay? So I'm not gonna go through the rest. You get how I got those values now. Let me just rewrite them. Root 3 over 1. Okay, so girls, that's where the exact values come from. It comes from this special triangle using 30 degrees, 60 degrees, and 45 degrees, okay? Yeah, they are your special values because these values can be used later on to find exact values of higher angles. Okay, so for example, later on year 11, if you wanted to find the exact value of, let's say, sine 225 degrees, okay, this is the same thing as writing sine 180 plus 45 degrees, and we know what sine 45 is. Later on, I'll tell you how to find the rest of that, but just memorize these exact values because it'll help us to find exact values of higher angles. Okay? For me to continue explaining this, I have to explain the unit circle, which is a bit later on, but just know that these are very important values. All right? To further apply this now, girls, I want you to look at example 11. I wrote the problem up, girls, if you just want to have a look. This seems like a very simple problem. Find the unknown length. But the difference in this problem and what we're doing today, they want you to find x in exact value. So you can't just simply put it in the calculator and give me a decimal number. That's not what they want. Okay? So do the same thing. That's your opposite. This is your adjacent. So what am I using? Tan. So tan 60 is equal to what? X over 12. Now, in most of your situation, what we used to do was do x is equal to 12 times tan 60 and just put it in the calculator, right? Well, we can't do that anymore because we know what tan 60 is in exact value. Root 3. Yeah? So this answer in exact value is just simply 12 root 3. That's what they want you to do from now. Okay? Let's just do one more just to clarify. The next example is to find an angle. So I'll just do it here, example B. Okay? So we know this is the hypotenuse. This is the adjacent. A and H, what am I using? Cosine. So cosine theta is equal to root 3 over 2. And hey, that looks familiar. Root 3 over 2. What is it for cosine? 30 degrees. So that's our answer. Okay, so this is the reason why we need exact values. Okay, instead of using calculator. Okay, I've dumped a lot of facts onto you girls. I can see that. So I'm hoping you girls will now be able to do the exercise. It's a very short exercise though. Okay, copy this down. Okay, now I need you girls to do exercise 9 and 4, and after that it's done.